Hi there. So in this video, we're going to take a look at Module 15, the measurement and calculation of inflation. And let me just kind of preface by saying anytime, I bust out the calculator over there, this is going to be a little bit more of a technical one, but it's not bad. And in fact, I think it's good to do these practice problems because they get you to really understand what exactly is CPI and how do we measure and calculate it. So throughout all of this, it talks about market baskets and price indexes and all kinds of things like that. This is a great example of how when you go to construct that basket of goods, of that 20,000 goods or 3 goods or whatever they are, typically what they don't do is they don't just say you get one thing in the basket. You would say, well, how many does the average consumer buy in a year? So if the average consumer doesn't just buy one Diet Coke, but they buy 1,000 of them, then that needs to be weighted differently in the market basket than just buying one. So that's some discussion about that and the CPI and how it's constructed and what goes into it, which I think is really interesting. I geek out on that. As we go further down, talks about the PPI and the GDP deflator. Those are two other they're price indices. A GDP deflator isn't exactly one, but it's basically the same thing. This is a neat little why this matters. Like if you'd be like, well, yeah, it matters to calculate, but like the CPI has an impact, on people's lives. So it matters a lot. And that's kind of a neat little explanation of how. So let's start with Module 15 and check your understanding number 1. So Module 15, now that I've told you, hey, this is a cool module, check it out. Number 1 says, consider table 15.1, but suppose the market basket is 100 oranges, 50 grapefruit, 200 lemons. So I'm going to write that here, 100 oranges, 50 grapefruit, 200 lemons. And then how does that change the pre-frost, post-frost consumer price index? Explain, and then generalize to say, how does the construction of the basket affect the CPI? So let's go and look at this 15.1 up here. And this one, it actually says that there are 200 oranges and 50 grapefruit and 100 lemons. So this one kind of flips the proportion of oranges and lemons in our index. And so we'll kind of just say, well, let's calculate. What would be the pre-frost? The pre-frost would be now 100 of the oranges times 20, right, as opposed to 200. And so we have 100 times 20 would be, right, $20, if I did that correct. And then the grapefruit is going to stay the same, right? And so that's 50 times 60 cents. And so that would be, hang on, I think I did the first one wrong. 100 times 20 cents, 10 times $2. No, I did that one okay. Man, I'm just going to do this because this is easier. 50 times 0.6 is 30. Don't know why that was so hard for me. Math hard, right? Math hard. And just so that I'm not crazy, I'm going to just double check. 100 times 0.2 is 20. Yeah. Whew. I was afraid I was going to look dumb, but I do that already. So we're over. Okay. Now the price of a lemon is 25 cents. So 200 times 25 is 50. And so we can see that then that's 100. And it used to be 95, right? The basket. And now the post-frost, how would that affect it? Well, 40 cents times 2 is, so that one's 40. And then that one is $1 in grapefruit, so that one's now 50. And then 45 cents, 0.45 times how many? 200 lemons is 90. And so it's 180. So it went from 100 to 180, and it used to go from 95 to 175. And in fact, we can calculate and see what would be the change here, right? So we used to say the new is 175 minus 95 over 95. That was the original one. And now the new one is going to be 180 minus 100 over 100. And this is going to be our percent change in the inflation rate, right? That's what we're kind of calculating is new minus old over old. So 175 minus 95, we should be able to do that in our head, is 80. And if we divide 80 by 95, it tells us that was an 84% increase in prices. But if we do this one, right, we see that's 80 divided by 100. That's an 80% increase in prices. So you can see that depending on what goes into the basket, like literally how many things go into the basket, you could say that the CPI changed in different ways. So the construction of the basket matters. That's what we can generalize by saying, in general, changing the components of the basket will change the CPI, right? Because you can see that it changes the percentages on that one. Okay, now number 2, for each of the following events, explain how the use of a 10-year-old basket would bias measurements of price changes over the last 10 years. So number 2, A, typical family owns more cars than it did a decade ago. And over that time, the price of a car has gone up more than everything else. But if we're using a 10-year-old market basket, that, for example, instead of a whole bunch of lemons, we only had one, then what that's doing is it's artificially keeping the CPI too low. Because now, in reality, people are spending more on cars. They buy more of them, and the price of them has risen faster than everything else. So we'd say by using an outdated basket, the CPI is too low because it doesn't include that new stuff, right? The more spending on cars. Virtually no households had broadband internet access a decade ago, but now many have it, and the price is really low. It's falling. And so by using an outdated basket, once again, in this case, right, the CPI is too high because in this one, and it doesn't reflect what they buy, doesn't reflect actual spending because it doesn't even include the broadband, for one, and for two, it's cheaper to get on the internet now than it was 10 years ago, but we haven't included that in our calculation, and so the CPI is too high. And so you can see how constructing the basket makes a difference on these. Now, number 3, CPI was 201.6 in 2006, 207.3 in 2007. Calculate the inflation rate. All right, so this is just going to be 207.3 minus 201.6 over 201.6. Remember, new minus old over old to do percent changes. So 207.3 minus 201.6 is equal to 5.7 divided by 201.6. So that's 2.8. So this is actually 0.028, right? Times 100 to get the percent means it's 2.8%, which is a fairly reasonable inflation rate, as it turns out. Now let's take a look at these multiple choice questions. If the cost of a market basket goes from 100 in year 1 to 108 in year 2, the CPI for year 2 is what if year 1 is the base year? Well, in year 1, we know if that's the base year, then that's 100. And so if it went from 100 to 108, then it's just 108, right? So multiple choice number 1 is D. If the CPI goes from 80 to 120 in 1 year to the next, the inflation rate over time is 50%. And there are a lot of students who don't know how to do that. You know how to do it. So number 2 would be 120 minus 80 over 80. That's 40 over 80. That's a 50% increase, right? Equals 0.5. So that's 50%. So we have C. Number 3, which of the following is true of CPI? It is the most common measure of price level. That's true. It measures the price of a typical market basket of goods. That is true. And it currently uses a base period of, that's a random fact, but it is also true. You do not really need to, that's a random fact, but E is correct for number 3. We do adjust the composition of the basket, even though the base number, the 100, is set to 1983. It's the actual components, like what we've been talking about this whole time. Those have been updated. They get updated all the time. Number 4, the value of a price index in the base year. Oh, that's easy. 100, B. And number 5, if your wage doubles at the same time as CPI goes from 100 to 300, your real wage dropped, right? Because that means if it went from 100 to 300, that the overall prices went up 200%. That's a lot. Sorry, you stayed where you were. Your consumer price index says the prices went up 200% and your wage doubled, so your wage stayed the same. D. I misspoke. FR number 2. The accompanying table contains the value of 2 price indices. For 04, 05, 06, the deflator and the CPI calculate the inflation rate from 04 to 05, 05 to 06. So we'll say 04 to 05, and this is the GDP one, and then this is the CPI one, and then we'll do 05 to 06, GDP and CPI. And so for this one, for 04 to 05, it's 100 minus 96.8 over 96.8. And then CPI for that one is 195.3 minus 188.9 over 188.9. And then we're going to come back in just a second and do the numbers in the calculator. And then for the GDP one, for the next one, it's 103.3 minus 100 over 100. And then for the CPI one, it's 201. Again, I'm just doing the new minus the old. Minus 195.3 over the old 195.3. So let's plug some numbers in and see what we get. For this one, we had 100 minus 96.8 equals 3.2 divided by 96.8. So that's 3.3%. 195.3 minus 188.9 is that divided by 188.9. So that's 5.4%. So you can actually see here that what happens from 04 to 05 is consumers see prices go up 5%. But what we see for the overall, like everything in the economy probably only went up 3%. So that means that like the prices of stuff that consumers are buying is rising faster than the stuff that maybe everybody else is. Let's take a look and see the next year what happened then. 103.3 minus 100. Well, that was easy, sorry. Divided by 100. Well, this is 3.3%. And it stayed basically, and that's not unusual. CPI doesn't really, and GDP deflators don't usually move around a whole lot. And there's some, but not a lot. Minus 195.3, 195.3 equals 3.2%. And so you can see in the following year, the consumer prices didn't rise nearly as fast for that one. So, okay, hopefully that helped you. I know it was a lot of numbers, but I think it's good to do the practice. See you next time.